Over the last couple of weeks, I've been learning CNC machining with the Makera Z1. Now, I'm not coming at this as a CNC expert. My background is CAD design, 3D printing, laser engraving, and product development, but CNC is still one of those areas I've always wanted to get more confident with. And that's why this machine has really interested me, because CNC can be intimidating. You've got tool selections, feeds, speeds, work holding, probing, tool changes, material choice, and if you get something wrong, it can go very, very wrong very, very fast. So for this review, I didn't want to just unbox the Z1, read the specs and call it done. I wanted to actually use it. I designed parts in SolidWorks, set them up in Makera CAM, ran them through the Z1 controller, machined different materials, and I did make a few mistakes along the way, and I ended up also producing some genuinely useful parts. So in this video, I'll show you what the setup is like, how the workflow works, what I managed to make, where I went wrong, and whether I personally think the Makera Z1 is a good option for makers who want to start getting into CNC. Before we get into the projects, it's worth quickly covering what the Z1 actually is and where it sits in the market. So at the time of recording, the Makera Z1 is available for pre-order at £999, with the pre-sale currently expected to run until June the 30th. If you are watching this after that date, then the pricing or offer probably has changed. I'm not going to go into too much detail on the specifications. You can see them on the screen here, but as you can see, the key bits, we have a 200 by 200 by 100 millimeter work area. The actual weight of the machine is 17 kilograms, so it is manhandleable. The overall footprint, so you're going to need a desk that's going to fit this, is 350 by 470 by 450 millimeters. And you can see the dimensions in inches there as well. Spindle power of 150 watt, up to 13,000 revs per minute. There is a integrated 1/8 inch collet, but also you can have bigger ones as well. And it does have a quick tool changer and built-in air cooling. NEMA 17 stepper motors, linear rails, belt driven, and you can see all the other specs right there as well. So it's a very capable machine with a wide range of materials. But let's get on with some projects so you can actually see what it can do. The Z1 arrived in a pretty substantial box, and the first thing I noticed during the unboxing was that everything was very well protected. There was a lot of foam around the machine, the main unit was wrapped in a protective bag, and the bag itself was strong enough to help lift the machine out of the box, which made handling it a lot easier. This unit is marked as the Founders Edition, established on Kickstarter, which is a nice little detail on the side of the machine. It gives a limited edition feel and makes this particular review unit feel a bit more special. Alongside the Z1, Makera also sent a lot of extras with this setup. I had the laser engraving module, the 4-axis module, the vacuum bed, the ionizer module, the low profile vise, extra milling bits, a material pack, probes, tooling, safety glasses, stop buttons, cables, grease, bare collars, and a really nicely organized toolkit. One thing to point out here is that I am showing the review setup Makera sent to me, so I do not want to assume every single buyer will receive exactly the same bundle. But as a package, this gave me a lot to test and a lot of future options beyond just basic CNC milling. Makera also sent over the Cyclone dust collector, which is designed to work with the Z1 to help remove chips and swarf while the machine is cutting. The Cyclone came with the main collector unit, the removable lower bucket, hoses, filters, vacuum attachments, and the required power and control cables. CNC work creates a lot more physical mess than laser engraving, so I was very interested to see how much difference this would make once I actually started machining parts. Plus, to separate assembly was mostly about getting the machine and the Cyclone connected properly. The emergency stop button plugs into the e-stop port on the back of the Z1, and I like that these are threaded locking connectors, so once they are fitted, they are not going to accidentally pull loose. The Cyclone uses two hoses. One connects from the Cyclone to the lower rear port on the Z1, which is the side that pulls chips and swarf out of the machine. The second connects through a side panel on the Cyclone and then into the middle rear port on the Z1, which appears to provide air back into the machine to help move chips towards the extraction point. There is also a control cable between the Cyclone and the Z1, which plugs into the EXT port, plus the separate power cable for the Cyclone itself. Once everything is connected, the two units work together through the Z1 controller, which means the extraction can be started automatically as part of the job setup. For my first proper project, I wanted to make something that was genuinely useful to me rather than just cutting a random test shape. So I designed an aluminium coin engraving jig in SolidWorks. The idea was to create a round jig with stepped pockets for different coin sizes, mounting holes, edges, and an outside contour cut. This was also the project where I filmed the full workflow, starting with the CAD model, then moving into Makera CAM. I exported the design from SolidWorks as a step file, imported it into Makera CAM, set the stock size and material as aluminium, then rotated the model into the correct orientation inside of the stock. For the main step pockets, I used a 3D pocket operation. I selected the pockets I wanted to machine and chose one of the built-in Makera tools, in this case a 3.175mm single flute flat end mill bit with a 12mm cutting length. One thing I found quite beginner friendly here was that once I selected the tool, Makera CAM automatically populated the recommended feeds, speeds, step over, step down values for the material. For this aluminium project, I mostly trusted the defaults. I wanted to see what the software recommended and whether the machine could produce a usable part without me having to manually calculate every setting from scratch. After the pocketing operation, I added contour operations for the 4 mounting holes and then the outside cutout. For the outside contour, I added a small extra depth offset of 0.5mm just to make sure it cut fully through the aluminium, even if the stock thickness was not perfectly exact. Once the toolpaths were calculated, I exported the file from Makera CAM and opened it in the Makera Z1 controller. The controller can connect by USB or Wi-Fi, and in this case, I connected over Wi-Fi. From there, I uploaded the G-code file, opened the job, and checked the preview before running it. Before machining, the Z1 goes through a really useful setup process. It asks for the probe tool, checks the workpiece position, shows a laser outline around the job area, and then asks for the correct cutting tool. After installing the metal cutting bit, the machine probes the tool height using the built-in probe point, then moves into position and starts the job. This was one of the points where the Z1 started to feel much more approachable than a traditional CNC workflow. You still need to understand what you're doing, but the probing, the tool prompts, and laser boundary check make the process feel far more guided. During the aluminium machining, I had the Cyclone running, and you can see it's slowly pulling the swarf away from the cutting area. It doesn't magically make the enclosure spotless while cutting, but it does help keep chips moving away from the front of the bed, and that makes the whole process feel more controlled. One thing I did notice on this project is that the stepped pockets took much longer than I had expected. Each lower pocket seemed to start from the original top surface all over again, rather than starting from the depth that had already been machined. That added a lot of extra machining time. I am still fairly new to CNC, so I do not know yet if that was something I set up incorrectly, if there is a better way to program it in Makera CAM, or if this is just how the operation behaves with my settings. If anyone watching knows the best way to handle that, let me know in the comments, because I'd be very grateful. Even with that, the finished aluminium jig came out really well. It was not just a test piece, it was a functional part that I had designed, programmed, and machined myself, and it gave me a lot of more confidence in the Z1 workflow. Afterwards, I also used the Cyclone manually with the vacuum attachment to clean the bed. For me, that was genuinely useful because CNC work does create mess, especially with aluminium, and being able to use the same unit for cleanup made a lot of sense. The next project was a bit holder made from the epoxy style tooling board supplied with the machine. I had quite a few Makera bit cases and screws sitting loose in the box, so I designed a simple organizer in SolidWorks to hold the square bit cases and hold down screws in one place. I did set this up again in Makera CAM, but I will not go through every single setting again because the overall workflow was similar to the coin jig. The main difference here was that the material and the type of part. I used a 2mm single flute spiral bit, and the job included square pockets for the bit cases, circular pockets for the screws, an L3D logo detail, and an outside contour cut. For this one, I also used tabs on the final contour cut so the part stayed attached to the surrounding stock instead of breaking free while the machine was cutting. That is one of those small CNC details that seems obvious afterwards, but it is something laser users and 3D printer users might not think about straight away. At the start of this job, I deliberately left the Cyclone off so I could see how much mess the material created. It did not take long before the whole area was covered in chips. That was actually a useful comparison because once I used the Cyclone vacuum attachment to clear the bed, it made it very obvious how helpful proper chip management is with CNC. The finished part came out really nice. The bit cases fitted into the square pockets, the screws sat neatly in their own holes, and the L3D logo detail gave it a more finished look. This is exactly the sort of project I like because it's not just decorative, it solves a real workshop problem, and it is something I will actually use going forward. After those functional parts, I wanted to try a 3D relief project in wood. I found a lion head STL and set it up as a relief cut in a fairly thick piece of wood, approximately 100 by 91 millimeters and about 26 millimeters thick. For this setup, I used the Makera low profile vise to hold the wood in place, which worked really well. The job started off great. The machine probed the tool, showed the outline, and the roughing pass began cutting the relief into the surface. The detail and contour lines were actually looking really promising. But this is where I made a beginner CNC mistake. The wood was too thick and the relief was too deep for the tool and collar setup I was using and that I had personally specified. As the job got deeper and the plastic collar on the bit started rubbing against the wood, it deformed the collar, so I had to stop the job and waste all of that effort. I do not see this as a machine failure, however. This was a tooling and setup mistake on my part. With CNC, you have to think about more than just the design on the screen. You need to think about the material thickness, the tool length, usable cutting depth, clearance around the tool, and whether the tool can physically reach the geometry you are asking it to cut. That failure, however, was actually really useful to me because it changed how I approached the next 3D relief test. Instead of using a thick block of wood, I moved to a much thinner brass plate where I could keep the depth under control and give myself a much better chance of success. For the final project in this video, I wanted to take what I had learned from the failed wood relief and apply it to a thinner material. So I used a brass plate and created a 3D relief pirate coin just for my children. In Makera CAM, the brass stock was set up as 100 by 100 millimeters and approximately 3.75 millimeters thick. This project used three main operations: a roughing pass, finer finishing pass, and then a contour cutout around the coin itself. For the roughing pass, I used a 2mm flat end metal bit with the default recommended settings. Then for the finishing pass, I switched to a 0.2mm 30-degree engraving bit to bring out the finer detail. Because this was a finishing pass after roughing, the software was able to directly cut to the final depth rather than stepping down like a roughing operation. For the physical setup, I placed the brass plate on top of a sacrificial piece of wood, lined it up against a right angle bracket and held it down using screws and a claw style clamp. I also used the probing and auto leveling features here, which is useful on thin metal plate where you want the machine to understand the surface properly before it starts cutting. This was a really satisfying process to watch. The roughing pass removed the main material, then the finer bit came in and started cleaning up the detail. After that, the Z1 cut the circular contour around the outside to release the coin from the brass stock. I didn't have the Cyclone running during this full cut, so there was some brass swarf left over around the job at the end, but I cleaned that up afterwards using the vacuum attachment once again. The finished coin was not perfect. You can still see the tool path witness marks across the surface. With more experience, more time, and probably a better finishing strategy or tool choice, I am sure I could improve the finishing surface. However, as my first proper brass 3D relief attempt after learning from the failed wood project, I was really pleased with the result. The best part is that the finished coin also fitted into the aluminium coin jig from the earlier project, which tied the whole process together nicely. A few smaller details are worth mentioning as well. Work holding is a big part of CNC, and Makera includes a few different ways to secure the material to the bed. During my testing, I used the flat hold down plates, screw head clamping, and the claw style clamps, and the low profile vise depending on the material in the project. I also tested the emergency stop button and it did exactly what you would expect. Pressing it brought the machine to a halt, triggered the red warning light, and then this can be reset by twisting the button back out and unlocking the machine in the Z controller. It's a simple thing, but on a CNC machine, this is really important. There is also a built-in camera inside the enclosure and you can view the job through the Z1 controller while it's running. It's not the highest resolution camera in the world, but it is useful as a basic monitoring tool, especially if you're not standing directly in front of the machine the whole time. Makera sent over quite a few other accessories with this setup, including including the laser engraving module, the 4-axis module, the vacuum bed, the 3D probe, the ionizer module, extra bits, the material pack, and the low profile vise. In this video, I have mainly focused on the core CNC experience, along with the Cyclone and the vise, because those are the parts I have actually had time to use properly. I don't want to rush through the other accessories just for the sake of saying I tested them. So for the laser module, rotary, vacuum bed, 3D probe, and ionizer of all things, I would like to cover those separately in future content. So give the channel a subscribe to make sure you don't miss those, because I'll be going through them in good detail and properly. So after spending time with the Z1, designing my own parts, making a few mistakes, and machining plastic style tooling boards, aluminium, wood, and brass, I feel like I've had a proper first experience with this machine. This is not me claiming to be a CNC expert. I am still learning. That is also the point of this review. I wanted to know whether someone with CAD experience, laser experience, and 3D printing experience could come into this machine and start producing useful parts without being completely overwhelmed. And overall, I think the answer is yes. As long as you respect that CNC is still CNC, the Z1 makes a lot of the workflow more approachable, but it does not remove the need to think carefully about work holding, tool selection, material thickness, cutting, and depth clearance. So after spending the last couple of weeks using the Makera Z1, my honest opinion is that I really enjoyed this machine. And that might sound simple, but with CNC that actually matters. I've used more manual style CNC machines before, and although they can be very capable, I've often found the process a bit intimidating and stressful. With the Z1, I actually found myself wanting to use it. The footprint is compact, the enclosure feels well made, the lighting and visibility inside the machine are excellent, and the lid holds itself up open properly, which sounds like a small thing, but it makes the machine much nicer to work with. The quick tool change system is probably one of my favorite parts, and compared to manually changing bits with spanners and traditional collet setup, this feels much more beginner friendly. Combined with the probing, the tool height checks, and the laser boundary preview, it removes a lot of the uncertainty before you actually start cutting. I was also impressed with the results. The parts I designed in SolidWorks came out accurately, the coin fitted into the jig, the bit holder worked as intended, and the brass relief coin came out far better than I expected, especially for an early attempt. The Cyclone dust collector also proved more useful than I previously expected towards the vac room. It doesn't leave the machine completely spotless, but it does help move chips away from the cutting area, and being able to use it afterwards as a vacuum to clean out the enclosure is a really useful feature. In terms of negatives, there aren't many major ones from my experience so far. Makera CAM works and I was able to do everything I needed, but it doesn't feel quite as polished as some other software packages. I'd also really like to see clearer machining time estimates before starting a job, because for CNC work, knowing roughly how long a toolpath will take is genuinely important information. There were also moments where I could tell I was still learning, especially with the deeper wood relief and with some toolpath choices that probably made the jobs take longer than what they actually needed to. But that's also part of the point of this review. CNC still requires thought. You still need to understand the tool length, work holding, material choice, feeds, speeds, and clearances. The Z1 makes the process more approachable, but it doesn't remove the need to learn. For me, that's where this machine makes the most sense. I don't see it as a production machine for heavy industrial work, but for makers, designers, educators, prototyping, small workshop projects, and people who want to start learning CNC in a more guided and enclosed setup, I think it makes a lot of sense. I still need to properly test the laser module, the rotary, vacuum bed, 3D probe, and some of the other accessories, so I'll look at covering those in future videos. But based on my first couple of weeks with the Z1, I'm genuinely impressed. It made CNC feel far less intimidating, it helped me build my own confidence, and most importantly, it made me want to keep on learning. So if you found this video useful, please give it a like, subscribe to the channel, and let me know in the comments below what you'd like to see me make next on the Makera Z1. Thank you for watching and have a great day.